Hello everyone. This problem has been asked in GATE 2013 and it is of 2 marks. It was asked in GATE 2013 and the weightage is of 2 marks. Let us see what the problem says. The problem is that in the circuit shown below, if the source voltage Vs is equal to 100 at the angle of 53.13 degree volt, then the Thevenin's equivalent voltage in volts as seen by the load resistance RL is. And the options are 100 at the 90 degree, 800 at the angle 0 degree, 800 at the angle 90 degree, and 100 at the angle 60 degree. So from the problem, it is clearly from the this problem is from the network and electrical circuits, and this problem belongs to Thevenin theorem. So if you have a want to have a detailed concept regarding this problem and a brief discussion if you want regarding Thevenin theorem, you can refer this NPTEL lecture, that is 54, and the course name is Network Analysis by Professor Tapas Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur, and the YouTube link is also given here. So before we begin to solve the problem, let us have a definition of AC Thevenin theorem. So what is AC Thevenin theorem? So any two-terminal linear AC network can be replaced with an equivalent circuit consisting of a voltage source and an impedance in series. So this is two-terminal linear AC network and we can replace with an equivalent circuit consisting of an voltage source, that is V Thevenin, and an impedance in series. So this is AC Thevenin theorem. So let us solve the problem. So this is the given figure. Now for evaluating the Thevenin voltage that is seen from the load resistance RL, this load resistance RL, the load resistance RL. So first we have to remove the RL and we open the circuit across it. So let us write one point here for evaluating the Thevenin voltage seen by the load RL. We open the circuit across it. We open the circuit across it. Then the equivalent circuit will look like then the equivalent circuit will look like, so we have given with the source voltage Vs and the value is given as 100 and the value is given as 100 at the angle of 53.13 volt, and this resistance of 3 ohm, and then reactance of J4 ohm, and then we have current dependent voltage source. This value is J40 I2, and then in this side also voltage dependent voltage source. So this is 10 VL1, and the inductive reactance of J6 ohm, resistance of 5 ohm, we have opened this circuit and we are finding the Thevenin voltage across it. So if you want to find the Thevenin equivalent voltage as seen from the load resistance R L, you have to open the resistance and you have to find the voltage across it. So clearly if you open the resistance RL, then this I2 will become 0. No current will flow through this circuit as there is no closed path. Since there is no closed path, then the current I2 will become 0. This is VL1, that is voltage across reactance, inductive reactance J4 ohm. So if this I2 becomes 0, we have this current dependent voltage source. Since I2 becomes 0, this will also become 0 volt. Now we have to find the VL1. So what are the important point after opening the circuit across RL? As the circuit opens across RL, therefore current I2 will become 0 and this J40 I2 will be also 0 volt. So now we have to find this voltage VL1 so that we can see here that Thevenin voltage seen from the load resistance RL is nothing but 10 VL1. So we can also write Thevenin voltage is 10 VL1 as I2 current is 0. So if we find this VL1, then we can find the Thevenin voltage seen from the load resistance RL1, and current flowing this in this closed path is I1. Since we have seen that the dependent source in loop 1 is short circuited, because current I2 is equal to 0, therefore voltage will also become 0. So we can write VL1 equal to VL1, first we write I1. So I1 will equal to Vs divided by 3 plus J4 ampere, and this VL1 will be J4 I1, J4 into Vs 3 plus J4. Now substitute all the values. Vs is given as 100 at the angle of 53.13 degree volt, and 3 plus J4 will become 5 at the angle of 53.13 degree. So it will cut, so it will become J4 into 20 times. So it become J80 volt. That is 80 at the angle of 90 degree volt. Now the Thevenin voltage, we have seen that Thevenin voltage seen across the resistance RL is nothing but 10 times of VL1, 10 times of VL1. So it is equal to 100 at the angle of 90 degree volt. Now we will match the options. From the option we can say that C option is coming as the correct answer. Therefore C is the correct answer. That's all. Thank you.